Okay, so welcome to Dorkbot Cardiff number 13. We had 3 speakers scheduled for tonight, but unfortunately one of them is ill and couldn't make it. That's Alison Fielding, who's going to talk about augmented books. But we still have quite an exciting lineup with Michka Mélo and Hanappe live from the Sony Computer Science Lab in Paris, who are going to tell us about 3 projects they are working on, which all have to do with sustainability and how to use technology in combination with, I would say, nature and biomimicry to think about alternative futures. So I will give the mic to Philippe there in Paris. Roger, I think.
Yeah, can you hear me?
Yes, very well. Do you want to introduce yourselves?
So my name is Peter Hanappe, the Sony Computer Science Laboratory, and next to me is...
I'm Michka, and I'm also at the Computer Science Laboratory for now.
So we'll talk about 3 projects this evening, all very different, and all within the sort of topic of sustainability. The first project I'll talk about is called Peer-to-Peer Food Lab. Now, the sort of the start of this project is actually well, my sort of preoccupation with peer-to-peer systems and free software. I'm sort of free software advocate for the past 17 years, and I've seen the sort of open idea move to the creative communities, the Creative Commons license, and starting now with the open hardware and the Arduino. And it's I think it's like the right time to think about how can we move this peer-to-peer philosophy to the physical world. And I don't know who's in the audience, that's mostly hackers, but I think all of you recognize the importance of food. So I think it'll be interesting to see how far we get with peer-to-peer philosophy in terms of food production, food sharing, food composting. Traditional agriculture is organized very monopolistically, and the thing is, how could we change that where people actually work together to grow food and exchange food? So this is what we're going to try to do. So it's also thinking a little bit about social economic models that would make this possible. This is on one point, and the second point is what sort of technology would be useful to support these food systems. So I don't know, can I move to the second slide?
Yeah.
So our starting point is to give people like a starter kit, a small greenhouse with sensors in it and a camera and a wireless sensor network that we hook onto the internet. So people can send the data of the small greenhouse to a website, and this will be like the sort of starting point to start to collect knowledge about growing vegetables in your backyard, about exchanging food. So it's, this is the starting point of this, basically building the technology platform, and it started off a very interesting exercise. Yeah, in the next slide you can see one of the first prototypes that we made. It's not very elegant yet, but so we're improving on that. We really want to make like a low-cost, open hardware sensor box to do this. And then start gathering data about the greenhouse. Now the project, on the next slide, you can see one of the partners in Brussels who is participating also. This is Hanappe with her collective Okno. So you can see, you have an idea and what can this become in a city. It's really a beautiful garden, and it's actually producing a lot of food too. So it's a really nice platform to experiment. So we've set up a website. It's called the Peer-to-Peer Food Lab. It's really early that we're in this project. So anyone interested to help us developing hardware, developing software for analyzing data and image analysis for measuring vegetable growth, for example, web applications to plan food exchange or growing food, is more than welcome to join the project. So we'll do this in, in an open fashion using open leaving-free software. Now, of course, all the sensor networks in a sustainability group might say that's not very sustainable. So, oh yeah, right, this is another point here before I go to the next topic. So we submitted our project to the WeShare Fest Awards. I don't know if you know the WeShare Fest. It's a very interesting festival on collaborative economy. So we submitted our project to the awards, and please, everyone, vote for us on the website. So what I was saying, the sensor networks in itself are not very sustainable. So we're looking into that also. And for this, I'll pass the word to Michka, who will continue explaining that part of the project.
Okay, so this is a project we imagined together with Peter the last couple of months. It was inspired also from the work of Hanappe, whose garden you just seen before, and she also likes to work with bees. And so on the next slide, there is a little bit of the general scheme of this project. It's about really intelligent beehives. What we mean is a beehive that can monitor the health of the bee colony. So they have already been doing a prototype out of this, but the bees died this winter and they even didn't see it coming. So there is some improvement to do on this beehive. And what we are looking for now is size monitoring, so changing the design of how we monitor the health of the beehive, but also doing it using different energy sources and materials. Because as Peter mentioned right before, right now the materials used in electronics are pretty complicated and to produce and polluting. So the energy source we plan to use is called the microbial fuel cell, and for this we are teaming up with a group in Bristol who did a robot which you may know, which is called EcoBot. Which works using dead flies, and we want to apply the same principle with dead bees to power our wireless sensor network. And here at Sony, what we are trying to impulse now is the development of biodegradable and biosourced electronic circuits to monitor this beehive. So really a radical shift in the materials we use to create these circuits. And such material include, for instance, beta-carotene that you can extract from carrots, indigo, which is used now to color jeans, and you can extract from a plant, and melanin, which is the pigment which colors our skin. So, yeah. I don't know if you, can you see the other slides afterwards, or is there a technical problem?
No, it's okay. This is next slide.
Okay, it's strange. I think we have some video frozen or something.
You don't see the slide anymore? Or?
No, but that's not a problem. We can do it like this.
We can see you, and we're still okay. Yeah.
Okay, so I guess so. I don't know if you passed already a slide with the bee frame.
We have one with a table with a laptop, and there is a frame.
Okay, so that's the right one. So on the left side, you can see a frame that you put in the beehive where the bees build wax and honey. And on this frame, we inserted. You can go to the next slide. We inserted small thermistors. There is a close-up on the next slide, which are basically resistors, which resistance varies with temperature. So they are really interesting for beehive monitoring, as they do very little radiation in the hive, so the bees won't be disturbed with electromagnetic perturbation. So we put 9 of these thermistors on the frame. And the idea is to put 9 on each frame and to have a 3D temperature picture of the hive which allows us to see the distribution of the bees in the hive, and to see also how big the colony is just by monitoring the temperature inside the hive. And so we are trying now to substitute this thermistor with sustainable electronics based on the materials I just mentioned before. So they are pictured on the next slide also. You can see the chemical structures on the left and the materials on the right. So the first one is beta-carotene, extracted from the carrots. The second one is indigo, which covers our genes extracted from plants. And the third one is melanin, which we can find on our skin, but not only. It is also produced by microorganisms and fungi. So on the next slide, you can see parts of our experimental setup. So you can see another kind of thermistor in black. And each little patch of copper foil on the left leaves a small contact with the huge ground to which the thermistor is attached. And here we will test the resistance of the different materials and monitor the temperature using the actual and working thermistor. And so we, on the next slide, you can see the more comprehensive monitoring system. So we have here Peter handling the pipette and taking some of the material solution to put it on the small experimental device I showed you right before. You can see also the two flasks are the products. We use the solvent, which is at the moment for experimental reason chloroform, but which we hope to substitute soon. And the melanin flask. And so we performed 2 experiments at the moment. They are not really positive, but we are moving on. We have seen more publications, and we will hopefully have some interesting results soon. We already have more strong theoretical basis. Yeah. So Peter, as you see, is in a kind of Robocop costume. So actually, as you can see, we are in a box. So why a box? This box is called a glove box. We can only interact with it with gloves, and Peter is outside. And the idea is to have a confined environment for 2 reasons. The first one is that we don't want oxygen to be in the box, so we filled it up with nitrogen. Because some of these materials, when they are in contact with air, oxidize and lose their semiconductor properties. And the second reason is that we are using chloroform, and that we don't want to breathe too much chloroform. So we spent a few days building up this block. I don't know if you want to add something.
I just mentioned that. I mean, it's also one of the projects. The glove box itself is a project in itself, so we built it from cheap materials that you find in a do-it-yourself shop. And this is also one of the parts that I think is important in the project. It's not just that we try to use biosourced and biodegraded materials, but also that we want to do it in a way that people can reproduce in a biohack lab or in a fab lab. So we don't want to use expensive high-end equipment to actually build these sustainable components.
So yeah, that's the 3 legs on which we try to set up the project now. Really, the true environmental sustainability and the low cost, and the fact that everyone can really use it and take it wherever it wants, as it is an open source and open materials project. Yeah, you want to add that? No? Okay. So we can now move on to the third project, which is a project I will start at the autumn when I leave Sony, at least for a while. So this project is called Metabolhomics. Metabolhomics without the H is a famous name in the world of biology, because it's the study of the metabolic reactions of living organisms that are the roots of their of the fact that they live actually. And I added an H because I want to do a project inspired from the study of metabolism, but regarding self-sufficiency at the habitat scale. So on the next slide is an example which will make it more clearer. So here is, for instance, a metabolic pathway we have nowadays in our house. We can call it the fried vegetable dish pathway. So the idea is that when we prepare a good fried vegetable dish, we import vegetables in the house. We cut them with a knife. There is some parts of the vegetable we discard, we don't use. The dices we have, we fry them in the pan using natural gas we also import in the house. And all this is made possible by the presence of three enzymes, we would say, three transformers of material and energy fluxes, which are the knife, which cuts the vegetables, the gas burner, which allows the combustion of the natural gas, and the pan, which allows to fry our vegetables. So as you see, in a self-sufficiency perspective, we are quite dependent from external materials, and we discard organic waste, which can be a resource actually for the house. So in the direction I would like to go, inspired from how living organisms work, is displayed on the next slide, is to develop new enzymes or new processors that would allow us to make the most of the resources we have actually, and to put into the house the most of the reactions towards self-sufficiency. So here, for instance, the organic waste we have can be first put in a bioreactor that would allow the production of methane. Microorganisms that are naturally present in our vegetable residues, when put under water, produce methane out of these vegetable residues. So this is perfect because with methane we can produce heat and fry our vegetables. But also with the methanization residues, in the end, not everything is transformed in methane. This we can put them in the composter and produce some compost. And if we recover the seeds at the beginning of our process, we can put them in the planter and grow vegetables again. So you can see that now we have a closed loop in the house. So of course this is far to be perfect, because probably the methane quantity wouldn't be sufficient using the vegetable residues only. So it's a work in progress, but that's the mindset of the project, really starting to close the loops inside the house using this with this metabolism metaphor. So on the next slide, you can see a first experiment we did besides from this project, but which is really like what I would like to develop. So with a few people in Paris, we gathered together in the park with the ambition to build composters. So we collected waste materials from the city and started to build our processor, which is a composter that works with worm and that can be used in apartments, which is really important for the city environments. And so we gathered, we were a few. The girls you can see who is explaining something is called Gaëlle. She works with the wood. I don't know the word in English, but she builds pieces of furniture basically. So she is very talented in building stuff. And she was explaining, and we co-designed in some way the laundry composter with her during the afternoon. We all have now a laundry composter at home. So this is the spirit of how I want to develop these new processors. The idea is not to have high-techy things you have to buy. It's also like in the Intelligent Beehive project, to have a really DIY basis to build these processors. And so the final, that's it. I would like to thank you for your attention, and also thank Paul and Dorkbot Cardiff for inviting us to this talk.
Okay, thank you, Michka and Peter. crowd now.
Okay, we can't see anything, unfortunately, but we can hear you, so it's okay.
Yeah, I think it's the Skype connection. Is there any question for Michka and Peter about any of the projects? Okay, Theodore, come on. I'll try and bring the microphone towards you.
Hi. Hello.
Hello.
Hi, quick presentation. What do you think of Monsanto, is that the name, who are patenting seeds? They've got a patent on seeds, Monsanto company. What's your opinion?
I'm sorry, I have really difficulties to hear the question.
The question
Was about Monsanto and the patenting of seeds.
Not much, very much in favor of that, and actually it's interesting to see how many associations are popping up for seed exchange, for example. So it's really good to see that this is happening. So I think that's something that we should support.
And I think it's implemented also in the peer-to-peer food lab project at the moment, also to have a seed exchange platform. As you have seen on the very first scheme we presented, no, maybe we didn't mention it on the first, but on the second, seed exchange is also part of this, as it seems to be very important for keeping natural seeds on the way.
Yeah. Mark?
Hello, can you hear me? Hello, can you hear me? Is there a lag here? Okay, well I'll assume you can understand me. My question is, in short, what is Sony's position in this ecosystem?
Yeah, that's a good question. I was expecting that one. But to begin with, we're a fundamental research lab in Sony. So we have quite a lot of freedom for our work. So, I mean, not everyone in Sony is working on open source, as you've noticed. But I mean, I'm here to bring the message. I think economy is changing. I think the economy should be changing. And so I try to do my best to get this message heard within Sony. Of course, I'm just one person in a big company, but I'm doing my best. And I think Sony has made lots of mistakes in the past, and I think they noticed. And I think they're thinking hard about how they want to develop as a company. So it's maybe a good moment to mention all these things.
Yeah, that's a good point. How long have you been working for Sony for, Peter?
For me, it's 10 years now.
10 years, okay.
Yes, I'm old.
Yeah, you're a proper Sony Yakuza. Any other question? Yeah, Leo?
Where do you trial your beehives? Have you done many trials yet, or?
Did we do any trials with the beehives?
Yeah. And where?
Oh, where? There will be, first trial will be in Brussels. We mentioned Okno, so we're setting up the first beehive there. I think we're planning the next sort of workshop in the middle of June, where we're actually going to try to put everything together. And the next one, actually we're also working together with Fab Lab Barcelona. I don't know if you know them. And so they also have a green Fab Lab. And the second beehive will probably be set up over there in Barcelona.
The project is called Valdora, and it's a very nice project. You can look it up on the Fab Lab Barcelona website. It also deals with self-sufficiency, and they have pretty amazing place to experiment. It's 130 hectares forest in a national park outside Barcelona. It's very nice.
Okay, anything else? Yeah, got one just about your biodegradable components, or how far are you from having an operating circuit, or which sort of circuit are you working on?
Yeah, we're still far from that. Well, the first thing that we try to do is actually a very simple component, a thermistor. And for us it will be a breakthrough if we already manage to do that. But research in, there's one, the product melanin has been studied fairly well, but then some of the other components like indigo and beta-carotene is fairly recent. There's a group in Austria, Linz, who's doing, I think it's most advanced in this topic, and they actually managed to build thermistors using indigo. So,
Transistors.
I'm saying transistors. So, it is possible. People have shown it, but then to do it using, you know, the sort of equipment that we're trying to build, I think that's still very hard.
As you said, the components will not survive in a normal atmosphere at this stage.
Actually, I think the survival in normal atmosphere will not be a major problem because we can encapsulate them afterwards. It's really for the experimental matters that when we prepare the solutions and so on, we are in the glove box to make sure there is no oxidation. But yeah, at the moment we have only infinite resistance measurements, and the calculus we did today showed that indeed the resistance are outside the range of our multimeter, so we have still to figure out how to get into maybe more thin films, homogeneous or something. Still a work in progress.
Okay, thank you. Right, any other question? Okay, I think we're going to wait a wrap.
Thank you very much too.
There is one more question.
Is your hope that we will all become food producers at some point in the near future?
Well, to be honest, I think many people already do. So if you see how many people actually have gardens and how many people are gardening, it's actually a lot of people. So it's just getting everyone together, you know, and I think it won't probably won't cover all of food use, but it can be a significant part, and then the sort of side effects of that can be interesting also. So.
Okay, thank you.
Okay, Peter and Michka, thank you very much. I'll see you in Paris next week, I guess.
Yeah.
In the meantime, thanks a lot for your presentation.